All right, so next up, we're going to do calculating theoretical probabilities with like sample spaces and stuff like that. If you remember from a previous lesson, sample space is how many different outcomes you can have. Now we're going to talk about rolling two dice, two number cubes. I'm not allowed to say dice in high school. So what ends up happening is if I throw two number cubes, I could get like a 1 and maybe another 1. So that would be one outcome would be a 1 and a 1. And then maybe I roll them a second time and I get a 1 and a 2 this time, or I get a 1 and a 3. I could do this all day. I could get a 1 and a 4, a 1 and a 5, or a 1 and a 6. And then I could come over here and I could do the same thing for the number 2. I could get a 2 and a 1, or I could get a 2 and a 2, or a 2 and a 3. And what we're doing is we're finding out all the different outcomes you could have. So this is just, there's 6 of them here. I could do the same thing for 2s. There'd be 6 of them. Same thing for 3s. There could be 6 of them. As a matter of fact, I'm going to use the power of Smartboard and cheat just a little bit, but you get the idea. How many different, the first question they want to know is show a sample space that has all the outcomes that are equally likely to occur. So the reality is I could get a 1 and a 1, a 1 and a 2, or a 1 and a 3. And we want to figure out just how many we can have. So I'm going to do that here in just a second. All right, so what I've done is I've gone ahead and made 1 through 6, but I also put 1 through 6 headed this way so that if I have all the 1 through 6 going this way, what I can do now is just come in and grab these and move them down, and I'm just basically making copies of all this stuff. So these are all the different outcomes that we could potentially have. A 1 and a 1, a 1 and a 2, and then I can go this way with it, and I can put these bad boys over here, like so. And these are all the different outcomes that I could have. Every single combination of rolling two dice, and there's going to be a lot of different. We're not asking for the sum right now. That would be a game called craps, which I'm not allowed to teach you because this is a high school venue. But the reality is, these are all the different ways we could do this. And if we go down 1, 2, 3, 4, 5, 6, and we go across 1, 2, 3, 4, 5, 6, 6 times 6 tells us exactly um, how many outcomes we have is going to be 36. There are 36 of these in total. So if we come up with some fractions for stuff, if we come up with ways to do probabilities like we're doing, our total number of outcomes is going to be 36. So let's go ahead and do some in that regard.